Welcome back to the Tech Talks Daily Podcast, a place where we demystify complex technologies every day and provide real-world examples of how technology is transforming businesses and reshaping entire industries. But we do all this in a language that everyone can understand. In today's episode, I'm going to be talking to Christopher Savoie from Zapata Computing, which is a Boston-based company that branched out of Harvard when its founders pioneered the field of near-term quantum algorithms. And as a leading enterprise software company for quantum solutions, the company is helping various industries prepare for a quantum future. So today, I want to explore the art of the possible. And I might even look in my virtual crystal ball and discuss what companies can do to be quantum ready, explore what a quantum future could look like, and also the industries that can benefit from quantum computing, and a few potential use cases too, not to mention learn more about their recent partnership with Andretti Autosport, which set off my tech spidey sensors and the reason that I invited them on the podcast today. So buckle up and hold on tight, because I'm going to beam your ears all the way to the US so you can take a deep dive into quantum computing. So a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
Well, I'm Christopher Savoie. I'm the co-founder and CEO of Zapata Computing. And we are a software company that focuses on how to do big computing problems that often utilize this new type of computing called quantum computing.
It's such an exciting space to be in at the moment, especially big computing and the problems that you're going to be solving, which will just completely blow people's minds. But I want to take you way, way back here before then. Can you remember where your passion for tech came from, or that moment that would put you on this path you're on today, your love of technology?
There are a couple, right? I think getting into science and nature and how things work was a really motivating factor. I think one thing, if I recall, was during the holidays and when I was 7 years old, I got a chemistry kit that I quickly used to do all kinds of reactions. And back in those days, it was going to the library to look up chemical reactions. There was no Google. But I figured out that you could take these alkaline metals and combine them with water and make some really explosive things happen pretty quickly. And that was actually, I remember that moment, to see something chemical react that way just by mixing something with water and seeing something burn. That really, sparked my interest in science and nature, and really wanted to learn more and more. And then I guess the other maybe formative moment was when I got I first had a Sinclair 1000 computer, and then later got a Commodore VIC-20. And when I started programming it, I really got this penchant for being able to program something in a logical manner. And I guess my whole career ended up somewhat a combination of those two kind of formative moments, where I found out eventually that we could use computers to really help understand some really complicated things that happen in nature. And really, that's been a theme of my entire career, using computers to understand biology, chemistry, physics in a number of different areas.
And there really is something magical about those formative years. And the amount of people that have been on this podcast and shared very similar stories about the wonder of being in that science lab at school, or playing with a Spectrum, a VIC-20, or a Commodore 64, a lot of people mention as well. But I don't know, there was something quite special about that time. And I think it's so important that we remember how far big computing's come, isn't it?
Yeah, absolutely. And I've always kind of analogized what we're going through with this revolution in quantum computing and big compute to that time in the 70s and 80s, when these computers were still quite nascent. I mean, you look at it today and they look quite primitive, the things that you could do. It was a magical time in that the use cases, the things that you could do with these machines were being developed by those young minds, thinking, how can I actually use this magical machine to do some pretty incredible stuff? Whereas the machines themselves were still quite primitive, 2K of memory, what you could do with them was quite limited, and still not very commercial in a lot of senses at that time. But it was that creativity, that moment of creativity, that gave rise to those use cases that we all know of today. Who would have thought that gaming would be a multi-billion-dollar global industry, looking at an EDAC computer or even an early PC?
Yeah, and do you remember when things like the floppy disk came out and there's 1.5 meg on each disk, and an office suite had about 15 disks, didn't it?
Oh yeah, but that was a big improvement over my cassette
Yeah.
player on my VIC 20.
But of course, it was that path that would lead you to Zapata, where you build quantum software for enterprises. So can you tell me more about the story behind the company and the kind of problems that you set out to solve with technology?
Sure. So I was working with one of my co-founders, Alana Spare-Gushik, who ran the theoretical chemistry lab at Harvard, where many of the initial quantum computing NISQ algorithms were developed, including the first one, VQE, this variational quantum eigensolver for chemistry, was developed in that lab. And I was working with him on classical machine learning that he also had in another section of his lab, and commercializing that in another company that we were applying to display technology, of all things, and this kind of semiconductor industry. And so that's how I met him. And as I was transitioning out and leaving that company, he said, well, but I may need your help here. We're starting Zapata Computing. I said, well, what is Zapata? And he said, quantum computing. You know, I have some folks who are studying quantum algorithms, quantum computing. I said, quantum chemistry? And he said, no, quantum chemistry on quantum computers. And I said, qubits? You mean like qubits? What are there, like 3 in the world now? You know? And he said, yeah, no, they're really expanding now, and Google's doing this and IBM's doing that, and blah, blah, blah. Come to my lab tomorrow. You got to talk to my guys about this. And I said, okay, qubits, but what do you do with 4 qubits? I can do that math on my hand, you know, using my fingers to count. No, this is expanding really quickly, and I'm getting, you know, requests to actually write software for these things, and there's no software company for this. You just come to my lab and talk to my folks about this. And so, yeah, less than 10 hours later, there I was in the Harvard chemistry lab, and talking with him and 4 others of his postdocs who eventually became my co-founders. So the 6 of us. So by the 6 of us were at lunch at a Mexican restaurant. Alon is Mexican by heritage. And we were at Harvard Square at a Mexican restaurant with Emiliano Zapata's mural staring at us. And by lunchtime, they had really convinced me that these early hardware folks were making real progress in creating machines that would be useful, and that there was a real need for taking the really primitive state algorithms and creating them into actual software systems that could eventually be used. And the way he posited this to me, proffered it to me, was that this was an opportunity to be Microsoft in the era of Altair. You know, mid 70s, you know, a lot of people don't realize that Microsoft existed before there was a PC. And these were hobbyist machines, and they weren't quite ready yet. And they had all kinds of bugs and problems. But there was a need for a software company. And if you were the software company that showed up at that time, you had a great opportunity to really create and craft an industry. And I was sold. So he took me back to his lab, and then he started calling people at IBM and at Google and introducing me as the new CEO of Zapata Computing that didn't exist yet. So that was an interesting foray into how it started. And then we were off from there. And, you know, a month or 2 later, we had gotten seed funding. We had spun out and brought some of the intellectual property from that lab into a company that was now focused on creating software for this new generation of computers.
Wow, what a great story. And of course, now it really does feel like momentum is building for quantum computing. Yes, there will be a few cynical people listening thinking it's still overhyped. So can you just set the scene and tell me more about how you actually see it impacting businesses? Because I get the feeling it's going to be happening much sooner than many realize.
It will. You know, really, I go back to the analogy. I mean, if you looked at an Altair machine back then, it wasn't very much of anything. Who would see the PC revolution and the microcomputer revolution happening if you stared at that? I looked up what in 1976, the most downloaded, actually it wasn't downloaded, you typed it into BASIC from a magazine, program was for the Altair in that year. And it was a graph of 2 variables, X and Y. So basically drawing a line on a screen. Now, that wasn't significant. And the things you could do with that weren't significant at that time. But the initial and fundamental work in creating algorithms was done during that era. And I think that's where we are today. So you could look at the machine and say, well, it doesn't do very much. Quantum computer today, well, with 5 qubits, I can do that quite easily on a pocket calculator, right? 20 qubits, not so much. 50 some qubits, as we've seen with Google, you can do some things that are impossible or intractable on a classical computer. So we're now at that kind of precipice that where we're starting to see quantum computers in very limited circumstances actually outperform classical computers at some tasks. So that trajectory is clearly evident now. What can I do today on a quantum computer that's better? There are more limited things that you can do. So using the statistics that come out of a quantum computer, you can enhance machine learning. You can do things that we are seeing in our work can actually have near-term impact on things that we're already doing in production. So if you're a company doing, analysis of your data using machine learning, or trying to be digitalized in how you look at things like your supply chain or your demand chain, these kinds of things can be enhanced using certain optimization routines and machine learning techniques that take advantage of these early quantum processors. So we believe that we're going to see, machine learning and optimization routines enhanced in production, in businesses quite soon. Then there's another category of algorithms and applications that will be further on that are actually in some ways more exciting because these are completely intractable. There is no classical solution for them. Things like quantum chemistry and other areas and understanding physical systems and simulation and quantum Monte Carlo simulations, and that will have effects in finance that will give us the ability to do things that are quite impossible to do now, completely intractable. So I guess there are two categories. There's the nearer term things that will start to get some advantage over the next year or two or three or four. I hate to pick a time. And then there are the things that are, 5-10 years away, but that are so significant to all kinds of activities, human activities, that will have effects on, how we predict weather patterns in climate change, for example, or how we predict how a pandemic might spread. And all things that really will have huge impacts on huge areas of human activity. And so that's the longer term, optimistic, but very realistic goals that we have with these computers that are really going to be change agents over the longer term in an exponential, quite literally exponential way.
And as you said, it is the very early days of quantum. We're limited to what we can do now, but that exponential change is on the horizon. Feels like we will reach a turning point sooner than most will realise. But I'm curious, is there anything companies can do to prepare and be quantum ready, or is it still too soon?
Well, I think that what you have to understand is that, the way that you formulate your problem in order to solve it is going to be fundamentally different when you're using a quantum algorithm and a quantum system to solve that problem. So the way you do the math is fundamentally different. So the way you're going to prepare your problem is going to be different. And that takes a certain type of thinking that is not necessarily there in a company today, right? So being able to work with partners to understand what your use cases are, first of all, that might take advantage of this quantum technique, and then turning your problems into a quantum solvable format is not something that's going to happen overnight. So the companies that choose to start developing that workforce and that capability today that can do that and start understanding how to do that are going to be at a significant advantage over those who wait today. And you can actually use some of these techniques to make quantum enhancements using classical machinery. So we at Zapata can use quantum techniques in this quantum formulation, but solve them today using classical computers to simulate the same kind of masks that we can solve on an actual quantum computer. And if you do that and you set up your infrastructure and your problem solution set and your software to be able to solve things in that way, it makes it rather straightforward when we do have those actual quantum computers come online that have a sufficient number and quality of qubits to solve those problems, so that you're not ripping up and replacing. So there is an opportunity to kind of get ahead of the competition here if you can set up your infrastructure, your software, and your systems to be quantum compatible, if you will, and forward compatible for quantum systems as they emerge.
And are there any particular challenges that you can foresee, that, especially when it comes to implementing quantum computing? Is there anything any advice you'd pass to listeners on that too?
Well, I think that, people sometimes underestimate what you need to do with your classical infrastructure as well. So you need to be prepared to have your classical systems input the data in the right way and pre-process the data in the right way to take advantage of a quantum computer. It's not like you can just have a shiny quantum computer show up at your data center or your cloud provider and you just plug it in and it works. This is a fundamentally different way of doing computation. And so it behooves companies to actually start to develop their workforce or their partnerships in a way that they can start to already transform their infrastructure so that you can make use of the classical data and components that you already have to do this big compute that fully utilizes quantum computing. And that means, workforce development, having a few people on staff at least who understand quantum computing, probably having good relationships with some of the quantum vendors, both on the hardware side and the software side, and having those relationships in place. And then starting to build and prototype things ahead of time so that you can understand what use cases in your industry, in your area, are going to be transformed by this technology, if not disrupted. And all of those are challenging. I saw some statistic somewhere that said that getting data scientists compared to a quantum scientist is a 300-to-1 ratio as far as the number of people out there that you can hire. So even finding internal experts and hiring those people is going to be a challenge. If it's already a challenge in data science and machine learning, this takes it to, a different level. I mean, a 300-to-1 ratio is pretty incredible. So you need to start now, or you might find yourself without the capabilities. Even if you have the domain expertise in your area to do this, you're going to need some quantum expertise. And that's a huge challenge, I think, for organizations and companies if they wait.
And I'm going to ask you to look into your virtual crystal ball here. Based on what we know now and what we think is going to happen, where we think we're heading, do you think, are there any particular industries that will benefit most from quantum?
Yeah, I think there are some that come to mind, and it really depends on where we're talking about time horizon-wise, right? So yeah. I think all companies are going to benefit from quantum-enhanced machine learning on the nearer term. So that's a very horizontal thing. Where is machine learning? Where is AI being used? It's being used across industries. So it's kind of hard to say, oh, this is the one. All industries that have large computational problems are in some ways leveraging machine learning to understand their data, understand their customer base, their marketing, and optimize in that way. So in that sense, it's a very horizontal technology. But when we look into the future to certain areas where there are going to be these really fundamental shifts, you can look at things like finance, where having full quantum Monte Carlo simulation of financial models allows you to brute force, basically simulate just about any scenario, right, that could happen in a market or an area. To be able to do that there are just too many variables to do that classically. But once you start to be able to do that, the repertoire of things that you can do and the scenarios that you can simulate just become incredible. So finance will be certainly an area. And you can see this in that banks are engaging with companies like us, with Zapata. They're publishing some of the work in the space, and they're hiring their own quantum scientist teams, actually, if you look across the industry. So that's one. I would definitely say chemicals and pharmaceuticals, because once we're able to use quantum machines to calculate the quantum systems that are chemistry at the end of the day, these are quantum systems, to really full accuracy, be able to understand how one compound is going to react with another before it happens. Think about what that does to pharmaceutical development and how much less experimentation you have to do, hit or miss, to come up with your drug. And think about the acceleration that offers to that kind of an industry. Same in chemicals, same in materials. When you can fully understand how this photovoltaic material is going to work for doing solar panels, or another material is going to work for doing battery energy storage. When we fully understand those systems without building them, that's going to revolutionize those industries. So those that deal with materials, chemicals, which is, again, a large swath of industry, but those are the ones that are really in aerospace is another, that automotive industry, that are going to really benefit from this absolutely transformative exponential technology in that area.
And just to bring everything that we've talked about to life today, before you came on, I was reading about your recent partnership with Andretti Autosport. So can you expand on that, how you're working with them and the kind of difference that you're hoping quantum technology will make with that partnership too?
Yeah, we get asked this a lot, particularly from people who are not really familiar with the behind the scenes of autosport. They see, just a bunch of people going zoom, zoom around the track, and they say, okay, what does that have to do with quantum computing? Is that just marketing? We've gotten that kind of a query and criticism. And the truth is, though, that there is so much data that's used. You have to imagine, these are, in an IndyCar or F1 race, you have these cars, 20 some cars going at 200 miles per hour around a track, different conditions every week. And this is life or death for the drivers, right? And the amount of data that comes out of these cars is pretty incredible. I think we get about a terabyte of data per car per race. At times, in the case of Andretti, that's 6 cars, and they have 20 years of historical data. And so the difficulty of and the number of variables that you have to keep track of is immense. And the margin for error, or the margin between number one and number two, is tiny. So you go, 500 miles at the Indy 500 around the track at 240 miles an hour, and the difference between number one and number two is half a second. So you can imagine 500 miles of that, a 3-hour race, right? That's your margin of error. So the computation that's going on behind the scenes is incredible. It's not just the data, but the number of variables that you're using to try and get that littlest, tiniest bit of advantage over the next person is amazing. There are 38 engineers on the other side at Andretti who are counterparts to us. And the head data analyst person on the other side, to give you some idea, is a PhD in aerospace studies from Purdue. So you can just imagine, the level of engineering that's going on behind the scenes there. It's pretty incredible. And so quantum computing is, on the near term, the quantum algorithms and enhanced machine learning that we can do is going to allow us to do things that make things much more predictive than they are today. So it's things like predicting tire degradation, predicting when a yellow flag for a caution will come out. Having that predictivity makes a huge difference in race strategy every day. And this is actually a problem for the infrastructure, because you can't do that all on the cloud. You have to create use that 20 years of historical data and the data that you got from last week and the week before to create a model, but you also have to update that model in real time at the track. So it's an enormous engineering challenge in how you do the data, in addition to the computational challenges that are there. So it's really a fantastic substrate upon which we can actually build capabilities, because most of our other customers don't have to deal with things in seconds and microseconds and whatever, and as many variables as we're looking at there, and have to do things both in learning on the cloud and in real time at the track. Most of those requirements are significantly less when you're trying to optimize a refinery for a chemistry company, for example. It's just not that fast, quite literally. So this is a great place for us to really cut our teeth on applying these technologies in a very real situation with real life or death decision making that has to be made, with some really powerful engineering behind the scenes to assist in generating that data.
Incredibly cool. And I've got to ask, it's that small boy that has watched the VIC-20 and to where you are now, where you see computer heading. What excites you about the future and the role that quantum computing and Zapata will play in that future too?
Well, I think that it's not an if at this point. It's a when will quantum computers, at what rate, disrupt what areas, right? But there's no doubt that being able to solve quantum systems and understand them, their fundamental level, is going to change how we see physical systems, and the world is quantum. So being able to understand quantum using quantum computers will allow us to understand the universe in which we live. And that really does harken back to, my original experiences and where my trajectory of my career has been. How can we use computers to really understand the world in which we live? And when you can do that, you can actually bring goodness to humanity in so many ways. And there are so many things like food security, climate change areas, and human health that I care about that will be positively impacted by this technology. There's no doubt about it, about if it'll happen at this point. It's a matter of when. And being a part of helping to make that when sooner is an incredible opportunity for me to be working with these incredible people here at Zapata to do that.
Well, we started the podcast today talking about your origin story, what put you on this path. And as we come full circle, I want to explore how none of us are able to achieve success without a little help along the way. So just to restore the balance in the universe, is there a particular person that you're grateful towards who helped you get where you are today that we can just send out there into the ether and a little thank you? Is there anyone in particular that springs to mind?
Yeah, I'd have to say Ken Kanichiro Suzuki, one of my mentors. He was at Nomura Research at the time that I met him, and actually doing a stint at Stanford. And he's a famous author on organizational IQ in business and whatnot. And, I had gone to him after, my first company at Dejima, and I was, between jobs and had some offers. And I said, oh, should I do this? Should I do that? Should I do this? Should I do that? He said, stop. I want you to read this book called Value Focused Thinking by this Harvard professor. Read this, understand what your values are, understand what you want to do in this universe, and then come back to me. But I won't talk to you until you've read this book and you've thought through it and come back with your own values. So I came back to him a week later, having read the book, and I said, this has been fundamentally world-changing for me because I've learned that I want to do something with computers applying to biotechnology, and I want to use it to do something in human health. And that's where the impetus for starting my second company, GNI, came from. And he liked the idea and the business plan so much that he actually joined me as my CFO. And we eventually took that company public on the Tokyo Stock Exchange in 2007. But it really did change my life in the way I think about things. I really look now not at, we could do this, we could do that, those alternatives, but really stop and think about what my value system is, what I want to do, what we're trying to achieve. And it's really, affected all of my decision-making personally and in business. To really have that kind of thing, take your values and look for the alternatives that fit those values. And it really is a great way to have kind of a compass in your life. And so I'm really grateful for what he did for me by bringing that, that concept and that framework to me.
Wow, what an incredible story, an incredibly powerful moment. I just love simply spending a bit of time with someone and giving them a book. Say, go away, read that book. And the impact that has had on your life is just phenomenal. So thank you so much for sharing that with me today. But before I let you go, for anyone listening, just wanting to find out more information about anything we talked about today, whether it be your partnership or the work that you're doing, anything at all, or contact your team if they've just got a few questions, what's the best starting point for everything?
You can always look us up on the interwebs at zapatacomputing.com. Feel free to follow me at CJ Savoie on Twitter as well, and you'll find a lot of hooks there to a lot of our social media posts on the company and whatnot. So I think from those two, you can contact us, follow us on LinkedIn as well. We have a bunch there. We're hiring. So please, if you're interested in joining the quantum revolution, please check us out there.
Well, I've absolutely loved chatting with you today. I think especially exploring the art of the possible. What can companies do to be quantum ready? What does that future look like? How do we prepare for it? And what industries will benefit from it? It's incredible. I think you've really set the scene today. I wish you the best of luck for the future. I will continue to follow your journey. It'd be great to get you back on in a year's time, see how things are progressing. But more than anything, just thank you for sharing your story today.
Thank you for having me, Neil.
As we explore the art of the possible together, what excites you about the future of quantum computing? What doesn't excite you? What concerns you? Whatever it is, I want to hear from you and hear your take on things and get your voice shared on this podcast, whether that be in a message or a future guest on the show. So as always, email me, techblogwriter@outlook.com, Twitter, LinkedIn, Instagram @NeilC.Hughes, and my website is techblogwriter.co.uk. If you or your business need help with business blogs and thought leadership content for your leadership team, or you want help launching your own podcast and letting somebody else worry about editing audio files and uploading to Apple Podcasts, etc., you can find out more about how you can work with me by visiting my website, techblogwriter.co.uk. I always like to finish every episode by saying technology works best when it brings people together. And the fact that you tune in every single day further proves that point. So I hope you'll join me again tomorrow. But a big thank you for listening as always. And until next time, don't be a stranger.